Oh, hi there. Thanks for showing up for your learning. This is Grant, the SAT Genie, and I'm going to be walking through practice test one on the SAT board's website. You can download this practice test by, I'll just show you the URL here. I'll put it in the description for you so that you know where to download these. These can be a really powerful ally in your SAT practice. And I absolutely recommend that you start any practice session by taking 3 mindful breaths. And here's your goal for these 3 mindful breaths is you want to take that first breath and feel what's happening inside your body. I feel that it feels really good to sit back on my heated blanket here and warm up my back. I just feel really good to be embodied. And then take your second breath and feel what's happening in your mind. Just be aware. And the more you do this, the more awareness you bring to your mind, the more it's going to relax. And this can really help you on the SAT because you're going to be at your best. And then one last breath and visualize your SAT success. Imagine that you're opening that letter and inside it says 1570, something truly spectacular, and see the chain of events that happens out from that amazing SAT result where universities open their doors for you, scholarships appear in your bank account, and careers open up for you. Feel that every time you practice, and you are going to feel awesome. You're going to get more value out of your practice, and you are going to crush your SAT. Ooh, that was a really long time to take 3 breaths. Okay, I'm going to breathe at a normal pace now. We're going to get started. Okay, let's go. Oh, it's also my office hours, so students may show up and interrupt. We'll see. Okay, here we go. So, question number 1. I'm actually going in blind here. I haven't really previewed these questions, but I'm going to try and explain all of them as best I can. So we have x minus 1 divided by 3 is equal to k, and k equals 3. So we want to know the value of x. Okay, it's 8. No, sorry, 10. 10. Okay, here's how we do it. So k is 3. So we just put it there, and then we recopy the question because it's not going to make our hand fall off if we can't do it in our head. And so there, I put in k as 3. And now we have x minus 1 divided by 3 equals 3. Here, just multiply both sides by 3. Clear that fraction out. The opposite of dividing is multiply. 3 times 3, okay? Then we get x minus 1 because this is canceling. 3 divided by 3 is 1. So we have 1 of x minus 1 equals 9. And then we add 1 to both sides. And that gives us x equals 10. Okay, there we go. Boop. Yeah. All right. Oh, very interesting. So we have a complex number question here that's absolutely not complex. Like, yes, these are complex numbers, but we don't have to operate on them. We just have to add them together. So 7 plus negative 8 will give us negative 1. So we can clear out those possibilities. It's definitely not 15. Could we add a negative number? This is like it's a 7-degree day, and then it gets 8 degrees colder. It's going to be minus 1. Okay. And then plus 3i plus 9i, well, that would be plus 12i. So it is a. Okay. So we just want to do this addition correctly. We're going to add 9i. The fact that I is negative, the square root of negative 1, has no special properties in this problem. It could be x. It could be just a typical algebra problem. All right. So here on Saturday afternoon, Armand sent M text messages each hour for 5 hours. Armand, you're very busy with text messages. And Tyrone sent P text messages every hour for 4 hours. Which of the following represents a total number of messages sent by the two of these texty gentlemen? Well, it's going to be this one. And why is that? Because Armand sends this many messages every hour for 5 hours. So that's how many text messages Armand sends. And then we're going to add to that the 4 hours that Tyrone was sending messages for. Okay, so it is this. And can we add those together to be 9MP? Absolutely not. No, suppose Armand is sending 0 text messages per hour, and Tyrone is sending 100 text messages per hour. Then this expression would be 5 times 0 plus 4 times 100. Okay, and that would be 0 plus 400. All right. So we absolutely have to keep these separated because we don't know M and P yet. So don't collect unlike terms. You can also think about this as like we have 5 marshmallows and 4 papayas. Okay, so that's what we have: 5 marshmallows and 4 papayas. We don't have 9 marshmallow papayas. Like, you can't put them together for some weird reason or multiply them for some weird reason. Like, what does that even mean, multiplying marshmallows by papayas? Okay, Kathy. She's a repair technician for phone company. Each week, she gets a batch of phones that need repairs. The number of phones that she has left to fix at the end of the day can be estimated by the equation P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. Okay, so what's the meaning of 108 in this equation? Okay, so here's our situation, right? We have this equation P, and it's looks like this when we visualize it. Okay, 108 would be the initial value. That's how many phones she has at the beginning of the week, and then as she works like 1, 2, 3, 4 days, it's about 4 days. She can knock this down. The amount of phones that she has left to fix goes down until it goes to 0, right? And then we don't ever have negative phones, so it's like kind of stops there. Okay, so this is after 1, 2, 3, just about 4 days of work. All right, and so that's this equation, and it has a slope, like the m value is negative 23. But this initial value b, which is 108, why am I using m and b? Oh, because we usually think about, and I have my students think about this as y equals mx plus b, is the equation of a line in what we call slope intercept form. And m is the slope, meaning the rate of change. And here, because we have minus 23 multiplying by days, as the days increases, the number of phones left to fix goes down. So it does not mean that she will complete the repairs in 108 days. No, she starts each week with 108 phones to fix. Yes, this is what means. It means on day 0, she's got 108 phones to fix. And that goes down by 23 every day. Yeah, so not these as well. She certainly doesn't repair 108 phones per day, because then she'd be done in one day. But she needs almost 4 to finish those phones. Aha! So now, what's the equivalent expression to this above? So here, let's so one thing we can do when we are subtracting polynomials from one another, I like to think about it as like this minus is just telling you to flip the sign of every term inside the bracket. So I like to do what's called distributing that negative. So this will be x squared y plus x squared y. So I will definitely have 2x squared y. So these ones are potentially correct, and these ones are not correct. And then minus 3y minus plus 3xy. Oh, wait, no, there's our like term there. So minus 3y squared minus 3y squared is actually plus 3y squared. So that will be no xy squareds. Sorry, that will be no y squareds. Sorry, these y squared terms cancel. So I have minus a minus, which is plus. I feel like I should write it out for you, because it's hard for me to just explain without doing it. So let me write it out. X squared y minus 3y squared plus 5xy squared. I wrote it out too big, didn't I? This is frustrating. It's so clear. Okay, so minus x squared. What? So I'm just gonna blah, blah, blah. Here, I know how I'm gonna show it to you. I figured it out. So now I'm gonna flip colors, and then I'm gonna do this. So I'm gonna have minus x squared y. That means plus x squared y, because this flips this thing's sign. And then I'm gonna grab this one, minus 3y squared. So that's actually plus 3y squared. And then I'll grab this one, minus plus 3y squared is minus 3xy squared. Okay. This here would cancel to 0. That's minus 3 things plus 3 things is 0 things. This here gives us 2x squared y. And this one gives us 2xy squared. So it's absolutely C is correct. And this would be a more fun question if they gave us like the factored form or something like 2xy times x plus y. These expressions would actually be equivalent. I can see that there's a greatest common factor, 2xy, and then there's an extra x here and an extra y there. So that's how we could factor out an x plus y. All right, let's keep going. That one is you really want to know how to add and subtract polynomials. It's definitely not something you do in the grocery store, but it's also definitely not hard. You just need to practice the rules and know the rules and drill this stuff a little bit. Doesn't take too much drilling. You'll know how to do it. Okay, now here we go. Here's a linear equation. H is equal to 3a plus 28.6. Remember I was telling you about y equals mx plus b, where m is the slope and b is the y-intercept. This stuff shows up a lot. Okay, so this is the model above to estimate the height of a boy in inches in terms of his age in years between the ages of 2 and 5. Okay, so like 2 is less than a, which is less than 5. When the boy is between those ages, this formula applies. Okay, based on the model, what is the estimated increase in inches of a boy's height each year? Well, that would be the increase in inches, which is 3. Okay, so every year we're going to multiply 3 by one bigger number, so it's going to get bigger by 3. So that's why this is correct. I don't know what any of these other answers, why they would even be tempting. Like this one here, 14.3 happens to be half of that. But why would you choose that? I don't know. Is this a third of that? I don't know. Like it looks like that's the only answer that is even remotely tempting. And then we jump over here and we have this crazy compound interest question. Look at how simple that question is. Look at how wonky that question is. Oh my goodness. All right. So it's not, they didn't even line up the formula the way I naturally line this up when I teach it to my students. So this one here, we're going to want to read it carefully and really walk through these bits carefully. So let's go. The formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. All right, which of the following gives P in terms of M, R, and N? Okay, so we want to solve this for P. Okay, we want to solve this for P. So this one actually is rather easy because all we're going to do is take this, multiply it both sides. So if it's downstairs on this side of the equation, it goes upstairs on that side. If it's upstairs on this side of the equation, it goes downstairs. And then we'll rewrite all those bits. Okay, so let's look for that. There it is there. Right there. Okay, see how this downstairs bit went upstairs? And this upstairs bit went downstairs? Okay, it looked like a really gnarly question, but it's really not that bad. Okay, and I might write this M like up here myself, but whatever. Okay, and now what do we want to? We want to talk about this one because it's immediately obvious to me, but it may not be immediately obvious to you. So let's see why. Let's say I'm going to really simplify this formula. So I have M equals A over B multiplied by P. Okay, and I want to solve this for P. So what I'm going to do is get out an inverse operations pen. And I'll even do this in 2 steps. I would normally do this in 1 step, but I'm going to multiply both sides by B. Okay, so I got BM. Sorry, sounds like bowel movement. I didn't mean for that to happen. It was a happy accident. Okay, so BM is equal to, this B will cancel that B, and I've got AP over there. BM equals AP. Cool. Let's get out my inverse operations pen again. And I'm just going to divide by A on both sides, because that's the opposite of multiplication, right? A times P. I don't want that. I just want P on its own. So let's divide both sides by A, right? So now P is isolated, and we got BM over there. Okay, so you got your BM separated from your P. I'm really sorry. It's what we call low-hanging fruit. Anyway, so there. So notice, this is what I want you to notice, that this B was downstairs, it went upstairs. This A was upstairs, it went downstairs. Which is Like, it doesn't matter all this junk and the wonky junk. It just matters that the wonky junk ended up downstairs there. And this wonky junk ends up upstairs. Okay. And that M is in the right place, which it is. I might write it up there, but it's algebraically equivalent. Okay. Now I told you that I would have done this in one step. And this is what my one step looks like. If M equals A over B, some fraction multiplied by P, then my inverse operation looks like multiply by the reciprocal. B over A, I multiply both sides. B over A. It's absolutely the same. I just do it in one line. So cancel, 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 cancel. P is isolated. And we got our BM all together over there. Over A. All right, let's go. I don't know. All right. If A over B equals 2, what is the value of 4B over A? There's also 2. Okay, let's take a look at Y. Okay. A over B equals 2. Yeah. So we got B over A on that side. Oh, that's a little awkward. Okay. Well, let's flip both sides here. This is one thing you're allowed to do. If A over B equals 2 over 1, then B over A equals 1 over 2. Okay. But then I'm wondering what happens if I get 4 up there. So let's multiply both sides by 4. Oh, so this would be 1/2 times 4. So 4B over A is equal to 2. It's very fast. Another way that we could do this. This is the more time consuming way, but you want to have different ways of doing these questions, even if it's just so that you thoroughly understand the question. So here's another way of thinking about it. A over 2, A over B is equal to 2. Multiply both sides by B gives you A, and then this B cancels that B because it's upstairs, downstairs. B divided by B will always be 1 unless B is 0. And if B is 0, this question can't work because they put B on the bottom. The denominator can never be 0. It would have been fun if they had undefined as one of their possible answers. That would have been a good one to put in there. That would have got a lot of people. They would have said like, ooh, I've heard my math teacher say the word undefined before. That's probably the right answer. Anyway, I shouldn't give them ideas. All right, A equals 2B. Or not 2B. No, it's definitely 2B in this case. This is not the language side. Okay, and so now if A equals 2B, then we can say 4B over A is equal to 4B over 2B. But then this B would cancel. How did I do that? Well, I know that A is equal to 2B, so I just substituted in there, and that's why it showed up there. So I get B over B, which cancels, and 4 over 2 is just 2. 2. Okay, so this one. Let's keep going. Oh, the system of equations. What's the solution? Oh, I love these questions. Oh, but they really did a jerky thing, didn't they? Well, where they didn't write the variables in the same order. Okay, so they are doing that. They're not being jerks. They want to know if you can do this correctly. So I'm going to rewrite it. 3x plus 4y equals negative 23. Negative x plus 2y equals negative 19. I just flip the order of those so that they line up over top of one another, and then it's a little bit easier to see what's going on. And now we can eliminate the y variables we could eliminate the x variables or the y variables. They're both easy to eliminate in this case. I'm going to multiply this equation by negative 2 to get a new equation. That's going to be 2x minus 4y equals negative 2 times negative 19 is positive 38. Okay, and now I'm going to add that together with this equation. 3x plus 4y equals negative 23. That will give us, when we add these together, 3x plus 2x is 5x. Oh, this is called the elimination strategy, and it's generally the faster strategy on the SAT. Although with this question, you could have also done substitution with another rearrangement, but I think this rearrangement is easier. Okay, so that's 3x plus 2x is 5x. Okay, 4y minus 4y is 0, and negative 23 plus 38 is 15. Divide both sides by 5, and we get the value of x. X is equal to 3. Oh, that's the answer then. Okay, because there's no other x that's 3. I'm surprised that they don't repeat any values. Maybe these ones they're trying to make look tempting. It's like, oh, it must be one of those two because it repeats a value. Let's just go ahead and test -8. Let's just test that point to check our answer. Okay. And this is what it would sound like. I'm not going to write it out. Um, so I'm going to put in 3 for x. So 3 times 3 is 9. I'm going to put in 4 times 8 there, but it's negative. So that's negative 32. 9 minus 32 is indeed negative 23. So that checks out for this equation. And now let's check that equation. Okay. 2 times y. So that's negative 16 minus 3 is indeed negative 19. So this point checks out. With these questions, you can plug and chug. It's as fast as like finding a solution. They're only giving you 4 options. We would have found it on the second plug and chug. If your mental math is fast, that could be your faster solution. But to be honest, I think I would solve this faster just doing it mental math with the system of equations than plug and chug here. So I think drill your speed on the systems of equations because they'll show up twice, maybe 3 times on the SAT. All right, g of x is equal to ax squared plus 24. We got a quadratic. We have a quadratic because x is squared. And you see, it just makes me so happy because I know some students are not getting these points and you're going to get these points, and that makes me happy. I'm also quite confident I'm about to get these points, and I like getting points. Let's go. Okay, for the function g defined above, a is a constant and g at 4 is 8. What's the value of g at negative 4? 8. It's 8 as well. And I know that instantly visually. This is why I know that. Because g of x is equal to ax squared plus 28. There's no bx term. Because there's no bx term, this thing has its vertex at the value 24 there. Okay. And it goes up from there and up from there. Wait, no, it doesn't. It goes down from there and down from there. It goes down like this and down like this. Okay. How do I know that? Because they told me g at 4 is 8. So that's over here. G at 4. So that's the 0.48. Now you're probably saying, how do you know that it has its vertex on the y-axis and that the y-axis is its axis of symmetry? Well, here's how I know. The b value in ax squared plus bx plus c gives you the slope of the parabola at the y-axis. In this case, b is 0, so it has a slope of flat. The parabola is rising until it gets to its vertex and then it's falling. So that's like a picture of its slope as it goes. So that's the slope there. So I'm going to show you this in Desmos because you're going to think I'm doing mathemagic and I'm just making this up as I go. No, I instantly know the answer. You can instantly know the answer if you have all the tools. So let's take a look at the tools. Here's another tool. Find its axis of symmetry. The axis of symmetry is negative b over 2a. Okay. In this case, a is a and b is 0. So this thing's axis of symmetry is 0 over 2a. 0 over 2a is always 0 for all values of a, except for if a is 0, in which case it's undefined. So this thing is flat there. Okay. And then how did that tell me that at negative 4, this would be also 8? Well, because it's symmetrical. All right. So let me show you in Desmos. I promised I'd show you in Desmos. Before I forget, let me show you. So here is this parabola. G of x is a function, and it's equal to a x squared plus 24. Let's put in a slider a. I can't see it, Grant. Yeah, it's because it's way up there. Like I told you. There's its vertex at 0, 24. We immediately know that if we know how to visualize this. This thing opens down because it goes through the point 4, 8. Okay, it goes through that point. So it actually is like stretched down quite severely. So we would need to calculate that its a value is -1, it looks like. I think that's binking the point. Yeah, so it's just got an a value of -1. So at least they went a little bit easy on us that way. Yeah, it was gone down 16, so that makes perfect sense. And then we would go ahead and substitute in and solve for that point. If you like wasting 5 minutes, you would do it that way. If you like saving time, you would do it instantly my way. I would be so confident with this, I wouldn't even bother checking my answer. Like, that's how confident I am in my visualization there. Okay, let's go. Oh, another system of equations. We got b and c and x and x. Wait, So this is actually three unknowns, three situations. So we're going to need to read this. In the equation above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. Whoa. What was the price per pound of beef when it was equal to the price of the pound of chicken? Oh, okay. So this is still a system of equations, and we want to find the solution to this system of equations. So what was the price per pound of beef when it was equal to the price per pound of chicken? Okay. All right. So a couple ways to do this one. We know we're looking for when beef was equal to the price of chicken. Okay. And we know that they were changing at different rates. Okay. The beef had an initial value of $2.35, and it was rising at 25 cents per week. Chicken had an initial value of $1.75, but it was rising at 40 cents per week. Okay. One strategy we could use is notice that chicken is outpacing beef at 15 cents per week. And then we would say, how many weeks is it going to take to close that gap? This would actually be my preferred strategy. And so then I quickly counted. Oh, after 1 week, the gap is 190 to 235. After 2 weeks, the gap is 205 to 235. And then I see it's going to take 2 more weeks because 33 more. So it's like 60 between those two. So it's going to take 4 weeks. So actually, X is 4. In the fourth week, their prices are the same. And then we can calculate what their prices are in the fourth week. It's going to be $3.35. Yeah, $3.35. They have the same price. So that's the answer. How would you do it if you don't notice like this trick about taking a look at how quickly the one is outpacing the other? Well, we can just set B equal to C. You can do it this way, and it's not much harder, and it won't take that much longer. B equals C. We want to know when beef is the same price as chicken. I still needed to figure out when it was, and then I calculated the price. Okay, and so then I put in my expressions. 235 plus 0.25x equals, that's the price of beef in any week. That's what it is. And then 175 is the initial price of chicken plus a change of 0.4x. I'm not going to write the 0.40 because the 0 doesn't change anything. That's still 40 cents. Okay, now my strategy is to move all my x's to one side. So that would be 2.35 equals 1.75 plus 0.4 minus 0.25. Okay, so I'm going to take that 40 cents and I'm going to subtract 0.25x from it. Okay, so that's how I move it, is by subtraction. And that gives me 0.15x. Remember, that was a number we used in our solution. And now I find what was the gap. So it was like 1.75, subtract that from both sides. You can do that in one line too. Move your numbers once and move your constants at the same time. And then you get 60 cents. 0.60 is equal to 15 cents multiplied by x. Divide both sides by 15 cents. Gives you 4 equals x. So we now found the week when this happens, and then substituting it in there is pretty easy. This is a quarter. We're gonna add a quarter for 4 weeks. We're gonna add $1 to the price of beef, so that's $3.35. We can even check it here. Putting in 4 there would add $1.60. And $1.60 plus the initial cost of chicken is also $3.35. So that is indeed when they have the same price, and so that is indeed the answer. 15 ways from every way. That's the answer. All right, so let's keep going. I'm not sure why the other ones look appealing. Oh, well, I don't know. I don't know what's up with the other ones. Okay, a line in the xy plane passes through the origin. And but I just want to go back here. Remember when I said that systems of equations are worth a lot of points? Yeah, it's showed up again in like question 9, question 11, both systems of equations. Master this stuff. Get those points. Okay, and notice I solve them very fast. You can solve them very fast too with practice. Okay, a line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on that line? No. This one. So it passes through the origin. So that's the point 0, 0. And it has a slope of 1 over 7, which means it is the line y equals 1 over 7x plus b, but b is 0 because it goes through the origin. A slope of 1 over 7 is very shallow, like that, meaning it runs 7 as it rises 1. So that's the point 7, 1. Okay. Not this. That's 1, 7. That would be like, that's a slope of 7, not 1 over 7. So it's very different. Very not that. This is a slope of 1. It's not that. And this is a slope of undefined, meaning it goes up infinitely fast. Or it's just the y-axis, this one. So it's very definitely that one. That one because we go over 14 and up 2. So that's the point 14, 2. We usually write 14 with the 1 first. 2. There we go. So that's that point there. And it's definitely on this line. I'm not going to show you in Desmos, but you can check yourself if you don't trust me. I don't know why you wouldn't. Okay, here we go. Okay, x is greater than 3. Which of the following is equivalent to this? Hooey. Okay, so these are rational expressions. And this one is a tricky one. I'm wondering if there's a shortcut, because there's sometimes shortcuts with these, but I'm not immediately seeing a shortcut, so I'm just going to crunch it. Okay, this is what I would have. So this whole thing is going to be equal to, I'm going to create a common denominator in the bottom. I'm going to use my common denominator creation purple pen. You don't need to bring a purple pen to the SAT, but you could. Okay, so I'm going to multiply that top and bottom by x plus 3, this fraction. Okay, x plus 3. I'm doing that because then I can multiply this fraction, top and bottom, by x plus 2. X plus 2. Okay? And then I will get a common denominator of x squared plus 5x plus 6 after I FOIL that out. By FOIL, I mean I actually do this multiplication. I only need to do it once because I got something times a thing. Something times it's the same multiplication on both sides. So I will get a common denominator. But the denominator will be a trinomial. This one, in fact, it's actually B. I can see the answer now. So yeah, there was a shortcut available. It was start the question and then immediately see the answer. I'll show you why. So here we go. When we multiply x plus 3 times x plus 2 in the denominator there, we do x times x, which gives us x squared, x times 2, which gives us 2x, 3 times x, which gives us 3x, and 3 times 2, which gives us 6. Hold on one moment. We're good. Sorry about the interruption. Okay, and then we simplify that by collecting these like terms in the middle. X squared plus 5x plus 6. So notice I did my rough work here outside the problem. I can do that in my head, but maybe you can't. So if you can't, you do the rough work outside your problem, and then you're going to write that out again down here. So now I have 1 over. That's this part. X plus 3 times 1 is trivially easy. It's just x plus 3. So I have x plus 3 plus x plus 2 because we're going to add the numerators together. So those are the two numerators divided by x squared plus 5x plus 6. So that's equal so far, right? And then we're going to say, well, that's equal to 1 over 2x plus 5 over x squared plus 5x plus 6. And then here, I can explain to you, I can show you, but I'll just explain. If I have like 1 over a fraction, like a over b, that's the same thing as flip this and multiply. So that would just be b over a. So now this 1 over all that stuff is just the flip it. So x squared plus 5x plus 6 over 2x plus 5. This one. Okay, cool. Let's keep going. We're almost to the code in our answers. Oh, I made it go away. with my clumsy fingers. Oh, because I was 13. There's 14 down here. Can't forget 14. Oh, yeah, this is a classic. This one is like one of the 15 hardest SAT questions. The answer happens to be that one. It's because I have this question memorized. I've done this question a few times. I didn't realize this one was on practice test 1. Let's go. Let's show you why. Okay. I've asked this before in a video. Here we go. 8x. Well, I can write 8 as 2 cubed. That is 8. But I need to raise that to the power x. And then I'm going to divide that by 2 to the y. Okay. And now I can, when I have a situation like this, where I have 2 to the a to the b, that's the same thing as 2 to the ab, multiply the exponents, or x to the ab. I mean, usually I'd use x there, but whatever, we have 2. Okay, so this whole thing is equal to 2 to the 3x divided by 2 to the y. All right, now when you are, so that is raising a power to a power, we multiply the exponents. I'm not going to explain why, because you can go watch my other video where I really go into depth on this question. I ain't got time for that. Well, you find the video. Okay, so now here, and my students, like if my students are watching this, they know this rule because I've practiced it with them. And if they don't know the rule, they can email me and get an explanation if they've forgotten, or go back to their notes. Okay, now when you are dividing powers with the same base, then we would look at it like this. Like if I have x to the 3 divided by x to the 2, that could be written as x times x times x divided by x times x. But it turns out that every x on the bottom subtracts 1 from the top. Every x on the bottom subtracts 1 from the top. But how do I know? How do I know how many 2's are down there? Well, there's y of them. So that would mean you would have final power 2 to the 3x minus y. Whatever y is, that would be the exponent. But we already know what 3x minus y is. It's 12. So now we can substitute that in. It's 2 to the 12. This answer, like I told you, I had memorized. Kind of wish I didn't have that memorized so that I could, like you, do that question for the first time and really have all the pleasure of doing it for the first time again. All right, let's go. Okay, so this one actually looks harder than the one we just did. Ah, cool. Yeah, a plus b is 8. Oh, neat. What are the two possible values of c? Cool. All right. Well, so we have some algebra to do over here. One thing that we know is like a times b is 15. I'll show you why. I'm going to simplify that bit over here and I'll show you. So ax plus 2 multiplied by bx plus 7. And now we do that thing I was showing you before. So this is going to be equal to abx. So a or and b are 3 and 5 or 5 and 3. Anyway, what are two possible values for c? Yeah, no. Two possible values for c. Oh, yeah, we're going to have to figure that out. Yeah, I'll show you in just a second for c. I was jumping ahead. Let me go back to my explanation. Sorry. Ax times bx is going to be abx squared. A times b times x times x. And then we do ax times 7. So that's going to be plus 7ax. And then we're going to do 2 times bx. So that's plus 2bx. Okay, and then 2 times 7 is plus 14. Okay, and now we can't really add that together because we don't know what a and b are yet. But here's the clue, okay? We know that this whole thing is equal to this expression. 14 is equal to 14. So that's a kind of clue that like that has to match that. Over here, I can simplify that a little bit. It would be abx squared plus 7a plus 2bx. That's factoring x out of those expressions and saying like I would add the coefficients together. One coefficient is 7a, one coefficient is 2b, and then plus 14. All right. We knew that 14 had to equal 14. So that's easy. But then 15x squared must equal abx squared. And we're also told that a plus b is 8. So now we're looking for numbers that multiply to 15 and add to 8. And those numbers are 5 and 3 or 3 and 5. Or negative 5 and negative 3. No, those don't add to positive 8. What am I saying? Of course not. It's -8. Anyhow, okay, let's keep going. So, um, so that's what we know, that either A equals 3 and B equals 5 based on, since AB equals 15. Like this part here has to equal this part here. Okay. So AB has to equal 15. So you can see that, right? Like this has to be 3 and that has to be 5, or vice versa. Or A equals 5 and B equals 2. So 3. What am I saying? 3, 3, 3. I was thinking about this too, actually. So that gives us actually two possibilities. Okay. So we've got this expression 7A plus 2B equals C, because C is the coefficient of the middle term. And the coefficient of the middle term can also be written as 7A plus 2B. Because these things are equal at the end of the day. And so the x squared term must equal the other x squared term. The coefficient of the linear term, the x term, must be the same, and so on. So if this is true, then we'll go with the first option. So that would be 7 times 3, which is 21, plus 2 times 5. So 31 is one of the possibilities. So there it is there. That's it. Okay. And watch, when I flip them, the other way will be 41. Watch this. So either that, which is 21 plus 10, which is 31, equals C, or this could be, well, I'll do it up here. C equals 7 times 5. I'm going to flip them, plus 2 times 3. Okay. 7 times 5 happens. So C in that case would happen to be 35 plus 6, which is 41. And there it is there. So that is correct. I like that question. It's a pretty question. I appreciate it. I appreciate them for putting it on. It's very tricky, but I appreciate it. Okay, so now we get to code in our answers. Oh, and I see trig is coming. I hope it's trig, not just similar triangles. Looks like similar triangles, actually. Yeah, if D is equal to E, then those lines are parallel as similar triangles. Let's go. All right. So T is greater than 0, and T squared minus 4 equals 0. What's the value of T? 2. Okay, 2 squared is 4. 4 minus 4 is 0. But we're told T is greater than 0. That's because T could also be -2, but we can't code -2 on the SAT, and we're now coding our answers, right? So they're always going to be positive numbers, positive rational or irrational, or positive integers. Okay, so yeah, let's go. All right. They're always rational numbers. I don't think they're ever irrational. Not that it would make that much difference for coding a decimal. Okay, 17. Summer camp counselor wants to find a length x in feet across a lake, as represented in the sketch. So A, B, E, B, B, D, and C, D on the sketch. So here the trick is to label them. AB was 1800. EB was 1400. And then BD was 700 feet, and this one has to be 900. Oh, and CD was 800 feet. Okay, all right. So here the trick is to notice that these two are actually the similar sides, like around angle D, and AEB, like this angle here, AEB, and BDC, or sorry, CDB have the same measure, right? So this side is similar to that side. Like this triangle here is twice as big. So the correct answer is 1600. Okay, 1600. Because I just double this. Now, why? Okay. In these questions, it can, if you're not immediately just like you're able to do that, line up your proper, like your same angles together, and notice that like this angle here and that angle here are also going to be the same, because this is what I call the kissing birds pattern. And once you see it as kissing birds, you'll never forget this stuff again. When you have two birds, okay, here I can draw a bird this way, and here's another bird this way, and I draw them kissing by drawing two lines that cross. This angle is the same as that angle. Okay, so the angles across. All right, and then that would also mean that this angle here is the same as that angle there, because again, kissing birds the other direction. Anyway, when you are working on similar triangles, and if you're at all struggling, rotate your triangles around so that all of your angles match. So I'm going to redraw this diagram in this little bit of space where I drew kissing birds. Bye-bye, kissing birds. You were so cute while you lasted. Okay, and so then I would redraw AEB. So that's A, E, B. And then I know angle B is the same as angle B on the other triangle. But that angle D has to actually come down here. So then I would draw it this way. BDC. Okay, so that's BDC. And my diagram is gross, but I know that angle is the same as that angle. And I know that angle is the same as that angle. So these are now similar and oriented the same way. I just rotate them in my head and orient them, but you may struggle with that. So redraw them until you don't struggle with that, and then you don't need to redraw them. Okay, and so then I just bring that side over there. So that's the side 800. And then I have this side 700 down here. So see, they rotated, they swapped spots. And then I know that this is the side I want to find, x feet. And then this side here was given as 1400. And this side up here is 1800, useless information, not necessary to the problem. I could use that to tell you that this was 900, but I don't care to tell you that. All right. Then the next thing I do is look for the ratio that scales this triangle up to that triangle. And I find that by doing 1400 over 700 to find the ratio is equal to 2. Okay, so then that's telling me that I would take this and multiply by 2 to get that. All that happens very fast because I've done this practice. So that's 1600. Let's keep going. 18. According to the system of equations, what is the value of x? All right, so let's do this in our heads. I'm going to eliminate the y because that will give us x faster. So I multiply the top equation by 2. And so I have negative 2x minus 2y equals positive 18. Add those together. 18 minus 25 gives me negative 7. And that's actually the value of negative x. So the answer is 7 here. X is 7. Now you're like, show me. Okay, I'll show you. I'm going to multiply this top equation by negative 2. Remember I said systems of equations are important? Here's the third one on the test, and we're not even to the calculator section. It might make an appearance on the calculator section, making this worth roughly 30 or 40 points. Like, big deal. It's a big deal. That's what I'm saying. Okay, so then I'm going to recopy that. So I'm going to have negative 2x minus 2y equals positive 18, because negative 2 times negative 9 is positive 18. And then I have underneath that x plus 2y equals negative 25. Then I add these together. Negative 2x plus x is negative x is equal to, add those together is 7. And negative 2y plus 2y is 0. So if negative x is 7, negative 7. I had it right up here. Okay. And then if negative x is negative 7, then x is equal to 7. Good. Okay. I sometimes make errors when I talk, write, and speak and do math at the same time. If I'm only doing 2 of them, I make fewer errors. All right, let's go. In a right triangle, one angle measures x, where sine x is equal to 4 over 5. Okay, so this is the 3, 4, 5 triangle. So you want to memorize this triangle. Okay, and it's called the 3, 4, 5 triangle. It's used by carpenters. A carpenter, if they want to make sure that like the corner of a wall and a floor is square, you can measure up 3 feet and out from the wall 4 feet, and then between those points you should have 5 feet, because 3 squared plus 4 squared is 5 squared, and this is the smallest Pythagorean triple, and it's the most commonly seen on the SAT. So here we are, and now so we know we have angle x here. All right, pion, like that. And we're looking at sine. So sine is opposite over hypotenuse. And now we want to know what's cosine of 90 minus x. Oh man, I think it's just the same thing, but let's see. So 90 minus x is going to be this angle over here, right? Like y. And so cosine is the same thing. It's 4 over 5. So the answer here is 4 over 5. It's the same. And if you just had to guess, just guess that number. How do I know? Well, the relationship between angle y and angle x is this relationship here, okay? Because we know that 180 degrees in a triangle, and this triangle has angle x. I'm calling that angle y for now, but I'm going to express it in terms of x in just a moment. X plus y plus 90, because those are those three angles added together, okay? And then let's express y in terms of x. So that's going to be equal to y, but I'm going to subtract x and subtract 90 from both sides. So that'll give me 180 minus 90 is 90 minus x equals y. Okay, so there. If I want cosine of that angle, well, that's the same thing as y, and that's measured from here. And cosine relates adjacent to hypotenuse. So those are the same. All right. And this is an identity that you can memorize, but as you've noticed, I don't have that memorized, but I can logic my way through it very quickly. This is how I don't have my mind cluttered with a bunch of facts that I memorize as like mathematical facts. Now you want to have the logic and then just apply the logic, okay? All right, a is 5 root 2, and 2a equals root 2x. What is the value of x? Oh, well, that's not that bad. That's not that bad. But if you don't have your working with radical skills yet, then this one is like a nightmare. Oh, man. All right. So here, we know a. Okay. Let's calculate 2a. Oh, that would just be 2 multiplied by 5 root 2. Okay. Which is equal to 10 root 2. But we're also told that that's equal to root 2x. So that's going to be actually x is 100. Okay. And that's equal to root 2x. Okay. So here's how we can do. There's a few identities that you need to know in order to do this, but I mean, like I can show you the calculator, but you won't have a calculator. This is not calculator section. I'm going to show you on the calculator anyway. Okay. Oh, I just made my calculator enormous. All right. Anyway, 10 times 2, but I take the square root of it, is equal to this number. Okay. I hypothesize, not hypothesize, I am 100% certain that if I do in brackets 2 times 100, I'm asserting that 100 is x, and then I take the square root of that, I get the same thing. So I know that x is 100. How does he know? How does he know these things? I'll show you. Okay, so here's some rules about radicals. If you have a radical like this, square root of ab, that's equal to the square root of a times the square root of b. You can break them up that way. And then, is that all we need here? I think so. Yes. Okay, so watch this. 10 root 2 is equal to the square root of 100, which is the square root of 10, multiplied by the square root of 2, which is equal to the square root of 2 times 100. And we were asked for the value of x. There it is, 100. Okay, so I've been chatting. This has taken me about an hour to chat my way through this. But as you've seen, like a lot of things, I have the answer immediately. And I believe with the right training. No, I don't believe. I've seen my students do it. Like with the proper training, they can go ahead and get this level of speed and get this level of understanding that allows them to see the quick shortcuts and crush these questions quickly. But now I'm going to model great study behavior, and I'm going to go ahead and open up the answers and check my answers against the answers. Here we go. Okay, and then, we're into the math here. So there we go. No, down. There, math test, no calculator. Choice D is correct. Okay, X is 10. Yes, we had that. Okay, choice A is correct. To add them together, the result is negative 1 plus 21i. So that's A. Let's just go back and check my answers just for fun. See if I made any mistakes. Because if I did, it doesn't mean I'm bad at this. It means I made a mistake and I need to know how to avoid that mistake in the future. So I said D and I said A, so that's good. And now for 3, I said it's definitely C. I was saying it's definitely C. I was circling those to say absolutely not. It's not a marshmallow papaya. It's not 9 marshmallow papayas because I don't know what that is, or 20 marshmallow papayas. Okay, so that one was C. C is correct. Okay. And then question 4, choice B. Okay. So we said B, yes. Great. Cool. And we can read their explanations as well to deepen our understanding, but I'm not going to do that for you. If you want to do that, I absolutely applaud you. Yeah, I think we had that as well. Choice C. Yeah, we did. Okay. Pediatrician. Yeah, it's 3. It's so obviously 3. I want to hear why the other ones were incorrect because I had no idea. Choice B, C, and D are incorrect and likely the result of dividing 228.6 by 3, 5, 3, and 2, respectively. Okay. Uh-huh. That's it. Dividing has no meaning in the context of the questions. That's why I didn't even see like where their wrong answers came from. It's just like strange. Choice B. Okay. Okay, so I said choice B, and I said that very quickly, but I'm kind of interested to what they say. Choice B is correct. Since the right-hand side of the equation is P times this expression, blah, but multiplying both sides of the equation by the reciprocal. Yes, that's exactly what I do, which is multiply by the reciprocal of the expression. And that's what I showed you here. Is like, if I have P times A over B, then we multiply by B over A, and then you get your BM separated from your B. Okay, let's keep going. Comedy gold. Brown gold. All right, let's go. Question 8. Choice C. Is that what I had? Watch it be wrong and I'll just be sad. No, I was right. Yeah, I was right. Yes, 2. I did that one fast. I remember. Okay, this one was absolutely B. B, yeah. Question 10. Choice A. Yeah. Yeah, we got it. Yeah. It's symmetrical. It's so fast. Symmetrical. I told you I wasn't even going to check my answer. And then I showed it to you in Desmos for like 5 minutes. But I had it less than 5 seconds. Okay, here. This one was D, absolutely. Yes, it is. Choice D. Choice D and then choice B. So let's see. Choice D, yeah, we had that. That's on the line. Choice B, yes, we spotted that pretty quickly. I was like, I wonder if there's a shortcut here. Yeah, it's like as soon as I FOIL that out and I see it's in the denominator's denominator, then I know that flips to the numerator, so I know it's this one. I don't know what these are. Let's see what they say is incorrect. Here. To rewrite this, multiply by, multiply that. What? Really? Why would you do that? How would you know to do that? Like, I know that it's going to be algebraically the same as what I did, but like I'm wondering how I teach a student to do that. Multiply. Yeah, right. Yeah, right. That's what you multiply by in this case. Gosh. I'm trying to now do that. Like, it's gross. Oh, I see. I see it. Yeah. My way's better because I understand it. Like I understand that this works, but I don't really know how to replicate that in a different situation or teach a student to do that. And I also feel that this only works like in these very contrived situations. Like my method is a method for all questions. This is a method that like works in a weird SAT type question that you're going to see every 5 years. So I don't like this explanation. Multiplying by that. Come on. You're just confusing people by saying that. There's way easier ways of showing this. Like this is not okay. It's not okay to say that that's like the road to a solution. Okay, give me a second question and see if anyone who's read this solution can do it. Okay, I want to talk through mine again. I have fractions to add. I create a common denominator by multiplying top and bottom. I ignore the fact for now that it's a fraction buried within a fraction. I just evaluate. Okay? That's what I'm doing here is multiplying to create a common denominator. It's very simple. And this is the same thing you will do on a lot of rational expressions questions. You won't do it their way of the fancy dancy stuff. If they're presenting that as a shortcut too, I had my answer just as fast because I can spot the right answer a mile away as soon as I start foiling that out. Gosh, no, I can look at this and say it's this one straight away. even without doing the operation, because I know that the trinomial will be in the numerator. So anyway, I normally love their explanations. I don't want to be too harsh here, but that is not a good explanation, and that is not the road to a solution that's repeatable. I don't think you can program a computer to do stuff like that. Okay, so this one I explained in another video, so doop. A is correct, yes, and we chose A. Yeah, A. We chose it a bajillion times. Okay, this one was fun. I like this question. I actually want to read their explanation for it. 15. They're going to say the coefficients have to be the same. Choice D is correct, yes, of course. One can find the possible values of A and B in this by using the given equation A plus B equals 8 and finding another equation that relates the variables A and B. Oh, that's a nice way of explaining it. I like that. And since this equals 15x squared, and we can expand the left side to obtain abx squared, then since ab is the coefficient of x squared on the left side, and 15 is the coefficient on the right side, then a multiplied by b is 15. Since a plus b is 8, then it follows that b equals 8 minus a. Oh. Are you serious? Okay, here, this is too step by step. This is going to take too long. You just want to look at it and say two numbers that add to 8 and multiply to 15 are 3 and 5. Like, you want to know that. That is something that you should have in your number sense. If you don't have that level in your number sense, then I don't think you're answering this question. Maybe some of you that are very good at following methods, but have poor number sense. In which case, I would say you've worked so hard on your methods. Work on your number sense too. It's worth it. Anyway, here's another thing that I want to plug right now. A plus B equals 8. The SAT creators love Fibonacci numbers. This cannot be overstated, how often Fibonacci numbers show up. And the Fibonacci numbers are this series: 1, 1, 2, 3, 5, 8. That's all I need to prove this. But they keep on going. 13, we'll see it later. 21. I actually didn't see a lot on this practice test, but sometimes you see a BM ton of Fibonacci numbers. And this goes on to 144, blah, blah, blah. 987, blah, blah, blah. Okay, keep going. All right, you just add the previous two. So if I add 1 to 1, I get 2. I get the next one. If I add 3 to 5, I get 8. Look familiar? Yeah. A plus B equals 8. So they lifted that from their favorite number sequence there. And then they plowed it in there. And then they said, let's go ahead and find these. And I kind of thought about it when we multiplied here and got 21. I was kind of thinking about it. But then it doesn't show up in the rest of the problem. So whatever. Anyway, their explanation is really nice. It's really nice. I like their explanation here. So you can read their explanation and learn from it. Oh, it sounds like I need a snack. Okay. No, the correct answer is 2. Yes, of course it is. Of course, the correct answer is 2. What else could it be? Oh, -2, but it's not that. This one here, similar triangles. Yeah, their explanation is going to be beautiful for similar triangles. 160, 1600. Yeah, great. Correct answer is 7. Yeah, we had the same thing. 4 over 5. Yeah, it's the same. I want to see their explanation for the trigonometry one, because I wasn't particularly satisfied with my explanation. And there was also a bit that I was, I had to derive on the test. I had to spend a little bit of time to remind myself that cosine 90 minus x is the same thing as sine x. If I visualize curves, I have that immediately, but I didn't go there because I didn't think it would be useful to explain to you. Anyhow, let's see their explanation. So the complementary relationship. So they're like, you are going to memorize this. That's what they're telling you to do. And I'm telling you, life is short. You got a lot of things you'd have to memorize in that case if you're memorizing that piece of information, especially since that piece of information is very easy to derive. Okay. Therefore, it's that. Yeah. So alternatively, so then they have alternatively my way. One can construct a right triangle that has an angle of measure x, and then that is 90 minus x. I called it y, but it's also 90 minus x. And then just have 5, 4, and then you go over here, bloop, 5, 4. I'm not sure why they didn't do sine of 90 minus x, because then you would have had to know that that was a 3 over there. Anyway, that would have been a harder question. The correct answer is 100. We had that too. Okay, great. So I scored 20 out of 20 today. Yay. And I only knew one of the questions before starting. So I'm pleased. I'm happy. But This is my favorite section, is the no calculator section on the SAT. I'm strongest at it. I make more mistakes on the calculator side, meaning I occasionally make one. All right. Okay. If you have any questions, absolutely up by email. Otherwise, thank you for showing up for your learning, everyone. That's it for me today. Bye.